Hey guys, I'm Mr. Post, and on today's video, we're going to be looking at classifying the different types of chemical reactions. This should be a relatively quick video, as we have about 5 chemical reactions to get through, and it shouldn't take us too long to do so. So let's get right into it. The first kind of reaction we want to look at is where one thing is produced. Okay, when I'm checking this out over here, I see I have magnesium oxide, and the key in a synthesis reaction, the key is that only one thing is produced. Sometimes it's actually called a combination reaction, okay, where one reactant plus another reactant is going to produce just one thing, one product. Whenever I see that, I classify that as a synthesis reaction. The second kind of reaction we're going to look at is a decomposition reaction. In a decomposition reaction, I want you to think of something decomposed. When something decomposes, it breaks apart, and that's exactly what happens here. The reactant is simply this. In this case, it's hydrogen peroxide, H2O2. It's going to undergo a change. It's going to produce two separate things. It's going to produce the things that it's made of, H2 and O2. So we look at this, I don't see more than one thing in the reactant. I don't see like something plus H2O2. I just see H2O2. So this right here will decompose or break up, and it's going to form two different things. Once again, the key to the decomposition reaction, one reactant. What's it going to make? Two or more different products. This is an example called a single replacement reaction. In a single replacement reaction, the element that happens to appear single is going to attempt to bump out one of these in a compound. And what potentially could happen is that H could end up being by itself and zinc in its place. So zinc is going to attempt to bump out the H and then be joined with the chlorine in zinc chloride. The H, which was originally with the chlorine, now is by itself on the outside. And that is an example called a single replacement. Once again, I think a good way to think of this is that you have an element that is by itself, and it is being added to a compound, something that is together. And one of these will be replaced. Okay, the single one bumps the other out. It doesn't always happen. Sometimes it happens, sometimes it doesn't happen. That's a different lesson called single replacement reactions, though. In a combustion reaction, what you see is a carbon-hydrogen compound. Carbon-hydrogen compound is going to react with oxygen to produce H2O and CO2. Anything that burns, like is on fire, is a combustion reaction, and the ingredients in a combustion reaction are always going to be the ingredients, the reactants, combinations of carbon and hydrogen plus oxygen. And if you recall, any fire needs oxygen, and one way to put out a fire is to smother it, and you smother it. When you do that, you actually remove the oxygen, okay? Because you remove the ingredient in the reaction cannot proceed, okay? Another thing here is that combustion reaction always produces H2O and always produces CO2 in gas forms. So it's going to produce H2O gas and CO2 gas. But once again, combustion reaction always has a carbon-hydrogen, always has an oxygen here, always produces H2O and CO2. And the last reaction we're going to look at here, okay, the last reaction we're going to look at is called double replacement. Very, very similar to the single replacement. And what I want you to see is that magnesium is going to trade places with sodium. And they're going to pretty much switch. This is called a double replacement. There's not just one replacement going on. This is going to replace sodium, and sodium is going to come back and replace magnesium. What you have on the other side now is magnesium with fluorine and sodium with chlorine. Okay, so just generally, they trade places. You could also look at it and say chlorine is trading places with fluorine. You can say that as well. But two things are being replaced. Now I want to look at a couple examples and see if you can actually pick out which one's the style of reaction it is. Okay, guys, here's our first example. Your job is to classify this reaction. We have 5 types of reactions. Once you press pause, go back through our notes, see which kind of reaction this matches to. But what you see in here is you see an element going to react with a compound to produce an element and a compound. And this one best looks like single replacement. Now I'm just going to scroll back through the notes, guys, and just show you this element plus a compound yields an element plus a compound. And if I just go backwards, here it is, element plus a compound will yield an element an element over here in a compound. That's a single replacement reaction. The next one I want you to check out is this one right here. Press pause, see what kind of reaction you think it is. Okay guys, this one has a compound and a compound. And it appears that aluminum and lithium are trading places, which would make this a double replacement. And it looks identical to this one right here, where I have a compound, once again from our notes, plus a compound, and they trade places. Okay guys, what do we have in this one? Please press pause and give it a shot. Anytime I have carbon in a varying number and hydrogen in a varying number, whether it be 3 and 8 or 4 and 10, etc., plus oxygen, that's going to tell me that this thing is going to burn, alright? This thing is on fire, it's going to burn, and we're talking about a combustion reaction. And the key to a combustion reaction is the carbon and hydrogen react with oxygen. That's my burning right there, and it's going to produce CO2 and H2O as well. Alright guys, these are just some examples. I have a whole worksheet on my website, for this, and you can classify that as well. But otherwise, those are 5 types of chemical reactions. Please memorize them and be prepared to classify any reaction according to those 5. Alright, thanks a lot for tuning in. Have a good day.